All right, we are going to learn a little bit more about bias and variability today, and some different things that happen when you sample and different ways that bias is created. First of all, you know that bias is something that sways a result one direction or another. It happens when there's consistent, repeated deviations of the sample statistic from the population parameter in the same direction. That probably is like whoosh over your head right now. But basically what that means is when something over and over and over again gives you a result that's different than what you think it should be. Okay? When you grab a sample of people and it is very different consistently over and over and over from what should have happened with the population, then you know there's bias. Okay? The best way to reduce bias, the only way really to reduce bias, is to make sure that you use random sampling. We've talked about other methods of sampling, like voluntary response and convenient sampling. Those kinds of samplings are automatically going to create bias, along with some other things, but those are definite predictors of bias. So if you want to reduce it, you need to make sure that you use random sampling. People sometimes think that taking a larger sample will reduce bias, and it won't. It will help you with some other things, but it will not reduce your bias. The only way to reduce it is to use random sampling. If you have small bias, it means your data will, if you were to think about putting it on a scale, it will balance on a scale, and we'll look at some examples in a minute. Then there's variability. We talked a lot about variability when we were talking about standard deviation, when we talked about IQR and range. Those are all measures of spread or variability. And so variability, again, describes how spread out data is. You want your data to be, if you were to grab samples over and over and over again, the same or different groups of people, but if you were to sample a population over and over and over again, choosing different subgroups, you would hope that you have similar results every time. And if you have similar results every time, then you have small variability. And that's what you want with your data, is to be able to grab samples of people and have similar results every time you do it. Okay? You're going to be more likely to have that happen the larger the sample size that you grab. So you reduce it by taking a larger sample. So we are looking at some data now that is on kind of like a target. I want you to think of one of these as one of those like Bosu balls, those exercise half ball things that you stand on and try to balance. So think about that. And we are looking at data, and I want you to figure out if they represent large or small bias and large or small variability. So you can see that this data here is clustered to one side, but it is very clustered. Okay? And so this one has large bias because it would not balance on a scale. The scale tips. And it has small variability because the data is very clustered. If we look at the next one, this data is definitely more spread out, but it has small bias because that Bosu ball, or that scale in this case, would balance. So if it balances, it has small bias. It has large variability, though, because the data is very spread out. This one has large bias and large variability. Again, that scale would not balance at all. It would tip, so it has large bias. And the data is quite spread out compared to some of the other pictures, and so it has large variability. And lastly, this one hit the bullseye. And this one has small bias and small variability. The scale would balance, so it has small bias, and the data is very clustered together, so it has small variability. This is what you're looking for. You're looking for, when you grab samples over and over and over again, you want them to not have bias, and you want your results to be very similar to each other. And when you get there, then you know you've gotten some good data. So good sampling has both small bias and small variability. Good sampling techniques includes the art of reducing all kinds of error. Because when you grab samples of people, there is so much that can go wrong. One of the things is to not grab them randomly. We've talked about that. And now what we're going to do is we're going to talk about all kinds of other things that can go wrong whenever you are sampling people. Okay, so basically, there's lots of errors that come in sampling. They sort of fall into two kinds of categories. The first kind is the sampling error, and those errors are just the kinds of errors that happen when you grab your group of people, okay? When you're trying to select your group of people. The first one is a random sampling error. Um, totally caused by chance, but it's describes that case where you grab a group of people, totally flukish, and for whatever reason, again, they're overrepresented in one area or underrepresented in one area or whatever. But it just is a sample by fluke chance where that doesn't represent your population very well. That's a random sampling error. And typically when that happens, there's undercoverage somewhere along the line. There's a group of people that have been left out or underrepresented, um, and that causes bias, okay? So sampling errors is one category of errors. Then this is what we talk about when we do margin of error. Then there's non-sampling errors. These are human kinds of errors, the errors that we can control and we can do something about, okay? And the first type of error is a processing error. And that covers mistakes in mechanical tasks. So things like they told you that they were 23, but you wrote down the number 32. Or they told you whatever, just mistakes in mechanical tasks, recording kinds of errors, human errors, those kinds of things, okay? Then there are response errors, and that's when you don't get the right data from people. There's an error in their response, and it might be because they lied to you about what they think, and it might be that they just simply don't remember. But for whatever reason, you got some incorrect information, incorrect response from somebody, which creates bias. Then there is non-response, which means you can't get data from somebody. I am sure that all of you have telemarketers that call your house all the time. And if you're anything like our house, we try not to answer the phone when the telemarketers call our house. But they are probably looking for some sort of data from me, and I am needing to be part of their sample. And when I choose not to give them information, then I am affecting their sample. And when I am not giving them information, then their sample size becomes smaller. And when your sample size becomes smaller, your variability becomes bigger, your margin of error becomes bigger, all of that good stuff. So it's really, really important once you've chosen your sample to be able to get data from those people that were chosen. It is the most serious kind of error. It causes big time bias, but it is a huge problem, especially in today's world when there's so many ways to figure out that we're getting a call from somebody we don't really want to talk to. And then the other thing that happens is the way the questions are worded, and we will talk about that in a minute. But for example, if I worded a question to Hutchinson High School students something like this, do you think the school cafeteria food is healthy enough to warrant paying enough money to eat school lunch, okay? That's probably going to sway you one direction or another. But if you word it, do you think that the school cafeteria food is healthy? Period. Okay? Then you can see that that question is worded with a little less bias, and you might be more apt to give an honest answer. Okay, so again, we talked about how when you can't get data from people, it is a big, big, big error, again, because your sample size becomes smaller, your variability goes up, your margin of error goes up, and that's not good. So you want to be able to do some things to reduce that non-response rate. And one of the things that people do is they train interviewers to keep people on the line longer. And I don't know about you, but if you've ever answered a telephone call from a telemarketer, you know that they are very persistent people, and you try to say no, I'm not interested in whatever, but they are super persistent, and that's because they've been trained. Sometimes what people will do is they'll send letters in advance saying, hey, we're going to be calling your house sometime this week. We want to just spend 5 minutes on the phone with you. It's no big deal, but just know that it's coming. And sometimes that has been successful. And another thing that might work is that if you keep calling these people back over and over and over again, eventually they might get so annoyed that they just answer the phone and say, oh, what do you want? Okay, I know that that's happened at our house. But in the end, if you can't get data from people, you've tried all of those things and you still can't get it, some things that you can do is substitute someone in your sample with someone else. So if you can't get, Chris Dobratz or whatever to give you a response, then what you might need to do is randomly select another person to participate in your study. The problem is it might not be a similar person. You might get a woman instead of a man, or a rich person instead of a poor person, or whatever, whatever. But that's one thing you can do. Another thing you can do is weight people's responses. So somebody's answer might count as two people's instead of just one person's. And again, you can see where that could cause a problem depending on who you choose to weight or how you choose to weight it, but it is something that you can do. All right, then, when you see data reported in the news, there are some things that you should be questioning before you believe this, because I think we've all heard how you can get statistics to say anything you want them to say, just about, and that is probably true. One of the things I want to know when I hear a piece of data reported is I want to know who conducted the survey. And here's why. If I was, again, asking that question about cafeteria food, I would want to know that it's probably a neutral party instead of, you know, the lunch ladies that I have to face every day in the lunch line. If they're asking me the question versus a neutral party asking me the question, I might be apt to answer it more honestly. What was the population? You want to know who were they targeting? Who were they referring to? Were they referring to just men, just women, old people, young people, a certain area of the country, whatever. But you want to know what was the population. How was the sample chosen? The key word you want to look for is randomly there. You don't want to ask, you know, if you see something that was reported a result from an online poll or a phone-in poll or whatever, and it doesn't use the word randomly, that is a big red flag. How large was the sample? Clearly you want to know if it was big enough so that the margin of error is pretty small. If they only sampled 50 people, it's not real reliable data. If they sampled 5,000 people, I might feel a little better about it. What was the response rate? That means how many people responded versus how many people were asked to respond. Clearly, if they, you know, said that they sampled 5,000 people, but their response rate was, you know, 3%, 3% of 5,000 people is not a whole lot. So make sure that you had most people participating. How were the subjects contacted? I think you can understand that people sometimes will answer more bluntly or honestly or truthfully in a phone conversation with somebody over something controversial versus a face-to-face conversation. So I would want to know, how were they contacted? Was it face-to-face? Was it a phone conversation? You know, I think if I were asked to ask the question, do you believe in gay marriage, let's say, people might be more apt to answer it truthfully if they were contacted by phone versus face-to-face. When was the survey conducted? You want to know that because if it's after a very important event, then it might sway people's results. So for instance, if I had said, do you think the government should offer critical aid to cities or towns or whatever that have been hit by a natural disaster? If you had asked that question right after Hurricane Katrina, you might get a completely different result than if no major national disaster had happened recently. And so you want to know, you just want to know the time frame so that if that's swaying results at all. And then you want to know, what were the exact questions asked. Here's an example of that. Do you, let's see, if, I'm trying to think of a good example here. You want to word it in a way that it is not biased. So if I said something to you like, do you believe gay marriage should be legal? That's one way to ask that. Or you could ask it, do you believe that we should, you know, break tradition and biblical truths known to this country for a long, long time and allow a woman and a woman or a man and a man to get married? Okay? Clearly, there's bias in one way you ask that and not bias in another way you ask that. And so you need to just really be careful about the way the question was worded. Okay? And make sure that it was not worded in a way that would sway one people one way or another. So that was a lot of information for one day, but hopefully that helps, and we will see you next time.